Why does it take a hot wire to get a hot air balloon off the ground? How can a steel block improve your golf game? What's the secret to fitting 9 separate tools into a tiny pocket knife? And how is garbage turned into paper towels to wash your hands? Find out next on Factory Made. The hot air balloon was the first successful aircraft to safely take off and land with people on board. It works by heating the air inside the balloon with a gas flame to make the hot air in the balloon lighter than the cold air outside, so we can lift off and carry the basket and the passengers up to 11 miles into the sky. But how do you make something that big light enough to fly while also making it strong enough to take the heat and carry passengers safely? Making the balloon starts with cutting out pieces of ultra-lightweight nylon with a heated stainless steel wire so they can be sewn together to make a giant balloon up to 10 stories tall. The nylon they use is called ripstop nylon because there are little squares woven into it to stop tears from spreading through the fabric. This is important because the finished balloon has to be airtight. Otherwise, the hot air could seep out and there won't be enough lift for it to fly. As an added safety feature, there's even an invisible silicone coating on the nylon that helps it repair itself. If the balloon gets punctured, the nylon can be rubbed together to activate tiny barbs in the silicone that bond the fabric back together. To be sure there are no holes or punctures in the nylon before it's cut, every inch of it is inspected on a lighted table. Then, up to 10 sheets of the nylon are rolled out and stacked on a cutting table, one on top of the other, and sliced all at once by the hot 1,000-degree wire into panels that measure between 9 and 18 feet in length. They use a hot wire because it makes a more accurate cut than scissors or a computer-controlled cutting machine. It's also the only way to cut through 10 sheets of nylon at once. The nylon doesn't catch fire because it's flame-resistant. But it does melt a bit, which seals the fibers along the cut to make the fabric less likely to tear. Once all the pieces are cut, they're sewn together with a unique sewing machine that uses 2 pairs of needles, for a total of 4 needles to stitch the seams. The multiple needles are needed to make a stitch called the 4-needle chain stitch. This type of stitch is able to flex in the wind to prevent tears. And if one line of stitching pulls out, the other 3 will still hold. All of the seams are backed with polyester tape to give them extra strength. Some of the seams are also lined with polyester rope. The ropes strengthen the balloon and tie into the rigging that connects the balloon to the basket. When it's all finished, it can take up to 600 pieces of nylon, more than 30 pieces of rope, and 4 days of sewing to complete just one balloon. While the balloon is being sewn, work is underway in another part of the factory on the burner that heats the air to lift the balloon. The burner is made out of stainless steel tubing that gets bent into coils. The tubing carries propane from a tank in the basket to the top of the burner where you see the flame on a hot air balloon. It takes 3 coils connected together, or a total of 33 feet of steel, to carry enough gas to fuel the flame. When it's finished, the coil is mounted to an aluminum plate that fits over the propane tank. A heat shield is then added to protect the passengers. When the burner is fired up to fly the balloon, it makes a 20-foot flame that typically burns at 30 million BTUs. 1 BTU is the same amount of energy needed to raise the temperature of a pound of water by 1 degree. This flame has 30 million times more energy than that. The final piece is a basket to carry the passengers. It's made of rattan, the dried stems of a tropical vine-like palm plant. Rattan is lightweight and strong, but not very flexible. So to start a basket, larger pieces of rattan are steamed in warm water. To make it flexible enough to be bent around forms into the framework of the basket. Once it's bent, the rattan is clamped down and left for up to 2 days to let it dry. Then, the large bent pieces are bolted into the framework of the basket. Thinner strands are stapled around the frame lengthwise. And even thinner strands are woven between them to fill in the basket. They can take up to a month just to make one basket. When it's finished, the basket is coated in polyurethane to protect it from sunlight and rain, and should last for 40 years or more. When all of the parts are finished, the burner is mounted to the top of the basket, and the basket is connected to the balloon. Then, all it takes is a blast of propane to ignite the flame and heat the air inside the balloon, and it's up, up, and away for nearly 2,000 pounds of balloon, basket, propane, and passengers. In a typical game of golf, the golfer will use a putter like this for about 50% of the shots, making the putter one of the most important clubs in their golf bag. It's used to gently roll the ball over the green to drop it in the hole. They're stressful shots, and precision is key, which is why putter heads have to be machined within a millionth of an inch. The putter heads start out as 12-foot-long blocks or billets of mild carbon steel that get cut by a bandsaw into smaller blocks of steel, one for each putter head. Mild carbon steel is steel with a fraction of a percent of carbon mixed in to strengthen the metal, while still leaving it soft enough to be machined and shaped. This particular steel also contains some lead to give the putter a softer feel to the golfer. The lead deadens the steel's natural tendency to vibrate. So when the putter hits the ball, the impact doesn't send vibrations up the shaft and into the player's hands. The piece of steel for each putter is 2.5 inches square by a little under 5 inches long and weighs about 2.5 pounds. To turn the block into a putter head, it's machined and milled down to about 12 ounces, or a little more than the weight of a can of soda. A computer-controlled milling machine slowly shaves away the excess steel in 3 key operations. First, the mill shapes the thick angular block into the thinner, more rounded shape of the putter head. It takes 20 different carbide cutting tools, each one more precise than the last, to carve out the rounded shape. The tolerance for error in a putter head is so small, each pass of the machine removes just 5/16 of an inch of steel. If the finished head is off by just 2/1000 of an inch, the weight of the putter head is changed by almost a gram. That's enough to throw off the balance between the putter head and the shaft and ruin the club. Once the initial shaping is done, nearly 2/3 of the steel block has been cut away. A worker locks the rounded head back into the machine for the next phase of milling. That adds a neck stem to the putter head so it can be attached to the shaft to make a club. The lubricant makes it hard to see what's happening. But this computer image shows what the neck stem will look like. It's extremely important to the performance of the club because the angle of the stem determines the lie of the putter. The lie is the angle of the shaft when the putter head is flat on the ground. If the lie is off, the shot will be off. The industry standard is a lie angle of 71 degrees, but custom clubs can vary by a few degrees based on the height of the golfer. Once the neck shaft is finished, the putter head is clamped into the machine one last time to shape the angle of the putter's face, known as the loft. The loft affects how much the putter face is able to kick or loft the ball into the air. Most putters have a loft angle of 3 to 4 degrees. Within that angle, the surface of the putter face has to be perfectly flat, within 1/1,000,000th of an inch. Otherwise, the shot could hook. Even this computer-controlled cutting machine can't cut within such a tiny margin of error. To solve the problem, a honeycomb pattern is machined into the face of the putter. It's an uneven surface, but the machine can mill all of the raised areas that contact the ball to exactly the same height, making the part that's actually hitting the ball perfectly flat. When all of the shaping is done, an engraving machine adds a sight line to the putter head. The sight line marks the center of balance for the entire putter. It's where the golfer should try to make contact with the ball. The finished putter head is sanded and polished on a belt sander before the engraved sight line gets a stripe of paint to make it easier to see. Then the putter head is ready to be mounted to the shaft. The shafts are made of hollow steel tubing that's cut to length and glued into the neck stem on the putter head. A rubber no-slip grip slides onto the upper part of the shaft, and the putter is finished. Unless a golfer wants a custom club. In that case, high-speed cameras can be used to measure the golfer's stroke. Minor adjustments can then be made to the neck angle and shaft to fit the club more closely to the golfer's height and style. Then it's time to hit the green. And if the putt misses, it'll be hard to blame the club. This popular pocket tool was originally made for the Swiss Army in 1897. The modern version holds 9 different tools, including a screwdriver, a can opener, a pair of scissors, and 2 knives. But how did they get so many tools to fold away in a space that's not even an inch wide? It starts with a powerful 120-ton press that stamps out the knife blades and other tools from huge 500-pound rolls of high-strength stainless steel. The steel is just 1/10 of an inch thick, and the finished tools will get shaved down even thinner so they can fold into the narrow slot in the utility knife. The ultra-thin steel has been strengthened and hardened by mixing it with other elements, including carbon and chromium. An element called molybdenum that's also used to strengthen steel for aircraft parts. Together, these elements make the thin sheets of steel so strong. It takes 120 tons of pressure and a steel die strengthened with even more carbon that is in the steel roll to stamp out the blades. When they have enough blades, the factory switches out the die in the press to make the other tools that go into the utility knife. While the other tools are being stamped out, the blades are dumped into a large vibrating bat that jiggles them in a bath of wet ceramic pieces to smooth out the rough edges on the steel. When they're finished, a magnetic conveyor belt separates the blades from the ceramic stones and carries them out of the vat. Now that the blades are fully shaped, the steel can be strengthened and hardened even more. That's done by heat treating the blades in a furnace for 20 minutes at 1900 degrees. The heat reorganizes the molecules in the steel so the blades are less likely to bend or break, and better able to hold an edge once the knife is sharpened. After the blades are cool enough to touch, they're placed by workers in a pool of detergent-like liquid that protects the steel as the blades rotate through a grinder. As the blades circle around, they pass between 2 grinding stones, one on top of the blade and one beneath it. They grind down the thickness of the metal by exactly 4/100ths of a centimeter, or a little more than 1/100th of an inch, until it's just 8/100ths of an inch thick. If the blade is any thicker, it won't fit into the tool, and if it's any thinner, it won't cut. It's such a precise measurement, a laser measures each blade, and a display screen lets the worker know in centimeters when it's just the right thickness. Only then do the blades rotate out of the grinding wheels and drop out of the grinder into collection bins below. The thinness of the blade and the other tools is critical when it comes to fitting all 9 of them into the handle of the overall tool. The key to putting it all together is stacking the tools between metal dividers in 4 very precise layers that are sorted by length so everything fits. The bottom layer has the shortest tools. The can opener at one end, a bottle opener at the other, and a sharp spike for punching leather called a reamer in the middle. A metal divider goes on before the next layer, which includes a metal hook and a pair of scissors. The saw goes on next. It's the longest piece in the entire tool, so it needs its own layer. The top layer holds the pocket knife at one end, the corkscrew in the middle, and the smaller knife on the other. When all of the tools are in place, the full stack loads into a machine that rivets a red plastic handle around all of the tools. Then, workers slide 2 extra tools, a plastic toothpick and metal tweezers into tiny compartments in the handle. All of the tools are checked to be sure they fold out. And with this in your pocket, you're as prepared as the Swiss Army for whatever you might need to jab, grab, open, or cut. You use them for just a second or two, and then they end up in the garbage can. They're the tan paper towels you find in restrooms, in schools, gyms, airports, and other public places. Every time you throw one away, you're sending it right back where it started, the trash. The paper towels you use to wash your hands start out as huge bales of garbage that get pulverized into an oatmeal-like pulp to make new paper. All of the garbage used to make the pulp is some form of paper. 80% of it is cardboard boxes, which is why the paper towels are cardboard brown in color. The rest is collected from household and business recycling programs, everything from junk mail to office paper to cereal boxes. To turn the garbage into the oatmeal-like pulp, forklifts push it into a huge underground pulping machine. It works like a blender, breaking the paper down into smaller and smaller pieces while it's mixed with water and a few chemicals. It takes about 40 minutes in the pulper for the waste paper to turn into pulp. When it's finished, it's drained out through screens. The baling wires, staples, and anything else from the trash that isn't paper is left behind so it can be scraped out of the pulper and thrown away. The pulp is pumped into a massive paper-making machine that's 2 city blocks long and 3 stories tall. Inside of it are 2 conveyor belts, moving at speeds of up to 50 miles per hour, fast enough to process up to 1,400 yards of paper every minute, or enough to stretch across 140 football fields. The fast-moving conveyors turn the pulp into paper by draining water out of the mix. Here's how it works. The mixture is sprayed onto the first conveyor, a massive 18-foot-wide absorbent mesh screen that starts to drain away the water. The screen carries the mix under a roller that squeezes out still more water. Then, the mix is transferred inside the machine to the second conveyor. It's called the felt, but it's not made of felt like you would think. Here's a sample so you can see the fabric. It's similar to a washcloth. Its job is to create a smooth surface on the top and bottom of the paper towel. Inside the machine, the soggy paper is squeezed between 2 pieces of the fabric to press out more water and lock all the individual fibers into place. When it went into the machine, the pulpy mix had a moisture content of about 95%. After the screen and the felter, the moisture is down to just 40%. The paper is now firm enough to roll over a massive 17-foot tall drum in the center of the machine that's heated on the inside with steam to 273 degrees. The heat from the drum evaporates out even more water until the moisture content of the paper is just 7%. A huge blade at the bottom of the drum scrapes the paper free. And finally, the new paper is revealed. The finished paper comes out of the machine on giant 16-foot rolls that weigh 16,000 pounds. That's way too big to fit in even the largest public restroom. And so heavy, the roll has to be loaded into the next machine with an overhead hoist. This machine is called a rewind machine because it unwinds the paper so it can feed through a cutter that trims the edges and slices the paper down the middle into 2 narrower strips. As the sliced paper comes out of the cutter, it's rewound onto another 16-foot roll. When the roll is full, it's popped out of the rewinder and moved to yet another machine called the converter. So the 2 narrower strips of paper can be wound yet again onto smaller rolls called logs. This machine also embosses the paper with a crisscross texture. The texture makes it more absorbent than a flat paper towel, so you can dry your hands more quickly. The textured logs roll out of the machine into a cutter that slices them into 13 individual rolls of paper towels, each one 9 inches across and 800 feet long. And that's how in just a single day, 100 tons of trash is turned into 700 tons of paper towels. Then in a split second, will be turned back into trash.